I know there's been some struggle here with trying to do lesson 22.4, 22.5. To be very honest, there's not a whole lot I can do to help you. I'm going to try to explain some things in this problem to kind of help you understand, but more or less it's just comprehension. You gotta kind of understand the whole idea with quadratics to implement in these, especially 22.4. So here's just a quick walkthrough. So this is the first example problem on the homework. And the difficult thing about this particular assignment is you're trying to figure out what is the most effective way, okay? So this is the second grouping of reasonings behind it, okay? So I'm going to try to point out some things to you. If b is equal to 0, in that case you want to take the square root, because that means there is no x term. That means you can get x squared isolated and take the square root. There are not many factors to check. That's when you want to do factoring, okay? So that's the methodology you want to use. If there's no other way, then that means you got to do completing a square. Now, this is just about picking the methodology. And I tell you all the time that they don't care about methodology on the test, but there are more efficient ways to do it. So let's take this particular problem, x squared minus 7x plus 10 equals 0. Factors of 10 that add to give me negative 7. That would be a negative 2 and negative 5. So x minus 2, x minus 5. Therefore, my solutions are 2 and 5. So I would have 2 and 5. So my methodology I would have picked right here would have been factoring. And the reason is there are not many factors to check. Okay, what are the factors of 10 that you would have to check? The factors are 1 and 10, 2 and 5. That's not very many. 2 and 5 works. Okay. All right, so let's go to the next problem. All right, so this next problem, you see there is no x term. b is equal to 0, okay? So let's reference again, what's it mean by b? Remember standard form, ax squared plus bx plus c equals 0. That term right there is missing. So because of b being equal to 0, in this particular case, we want to do taking the square root. That would be my methodology. Okay, so how do I solve? I've got 49x squared equals 144. Divide by 49. X squared equals 144 over 49. Then you take the square root of both sides. So x equals plus or minus square root of 144 is 12, square root of 49 is 7, and there are my two answers. Since this already has plus minus, I just do 12 over 7. So it's all about being efficient, being very efficient, figuring out what's the fastest way to solve. If you get stuck on the state test or any other, quadratic formula will work for every problem. Okay, it works for every problem, so you can just use it. But here it's just trying to basically challenge you as an honors class. Can you determine what the most efficient method is in solving? Let's look at another one. Okay, 4x squared minus 4x minus 9 equals 21. Okay, so let's get it equal to 0. So I'm going to move the 12 over. If I do that, I get 4x squared minus 4x minus 21 equals 0. Now, if I try to do factors, 4 times 21 is a negative 84. Factors of 84 that subtract to give me 4. So I start going through 1 and 84, 2 and 42, 3 goes into it, 28 times? 4 and 21. 5 won't go. Will 6 go? 6 goes in 14. Will 7 go? 7 won't go. 8. 8 won't go. 9 won't go. Or 7 will go. I'm sorry. 7 will go into it, 12 times. Sorry about that. Well, after that, I'm done. Because what's 12 minus 7? 12 minus 7 is 5, and 8 won't go. So I'm not going to get any factors that will give me, that go into negative 84, that give me a negative 4. Okay? So this is not factorable. All right, so now what do? Well, you can't take the square root because b is not equal to 0. So what they want you to do here is they want you to think about doing quadratic formula, okay? Or completing the square, okay? Because it's not factorable. So how do we complete the square? Okay, 4x squared minus 4x minus 9 equals 12, okay? So remember, with completing the square, you go through that whole process. But again, the whole idea is here, find a way that's easy. So the methodology is complete the square, but I'm not going to solve it that way. What I'm going to do is I'm going to use quadratic formula. Sorry about that. A little shift there. Okay, so I have 4x squared minus 4x minus 21 equals 0. So here's my A, there's my B, there's my C. So I'm going to make it a little bit smaller here, move it up. Now all I'm going to do is I'm going to plug that straight into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now what do I do? Now I just go through and simplify that. I got 4 plus or minus. Okay, so if you go back to module 22.3, this is a good review for that, where it talks about the discriminant. This is the discriminant. Depending on what kind of value it is, determines how many solutions. If it's 0, there is no plus or minus 0. That means there would only be one solution. If this is negative, you can't take the square root of a negative. Therefore, there are no solutions. But if this is some positive number, then you have a plus case and a minus case. So there are 2 solutions. Okay, so if you do that, that's 16. That's 84. So I'm going to do that real quick. 16 plus 4 times 4. So that's 352. All over 8. Now I have to simplify this radical, square root of 352. So I try to think about what are factors that will go into 352 that are perfect squares. So 16 will. So I have 4 plus or minus the square root of 16 times 22 all over 8. What's the square root of 16? That is 4. So I have 4 plus or minus 4 square root of 22 all over 8. Okay, now I'm going to slide this up here. So what I have is I have 4 plus 4 square root of 22 over 8. And then I have 4 minus 4 square root of 22 over 8. Now that's not simplified because 4 will go into 8, 2, 4 goes into this, 1, 4 goes into that 1. Same thing here, 2, 1, 1. So what am I left with? I'm left with 1 plus square root of 22 all over 2, 1 minus square root of 22 all over 2. And those are my 2 solutions, okay? So this assignment is a little tricky because it's challenging you to understand what are all the different methods we've learned to solve quadratics and find the most efficient way and select that choice. But then how you ultimately solve it is up to you. Quadratic formula will work every time and it will give you square root answers. Now, what about lesson 22.5? So in lesson 22.5, it says, the first one say, how many solutions? And you just put it in your calculator. You look at the line and the parabola and see how many times they cross. Does it cross twice? If so, it has 2 solutions. If it crosses once, it has 1 solution. And if they don't cross at all, they have 0 solutions. So this one says solve the system of equations graphically. Okay, so what's that mean? I'm going to put this in for y1, this in for y2. So I go to my calculator, y1, parentheses, x plus 3 quantity squared minus 16, and then 4x minus 4. Go to zoom 6, start with a standard graph first. So in this case, in a standard graph, I can't see where it intersects twice. I can only see one. So you got to change your window. In this case, I need to move down further. So I'm going to change my y-min to -20 and then graph. Now I can see my whole parabola, and I can see my line intersect it in 2 places. Now what do I do? After I've changed my window and I can see where it intersects twice, I go to second trace, number 5, intersect, and then I just press enter 3 times. Now, when I do that, I get the intersection 1, 0. So in this case, one solution is 1. Now the other one, I go through the same process. Second trace, intersect, press enter twice, but this time I have to move my cursor down near the other intersection point at the bottom, and in this case I get -3, -16. So my solutions are 1 and -3. So you don't have to do it algebraically or whatever. Okay, so this one says graphically, I use the calculator. This one says do it algebraically. But guess what? I'm going to do the exact same thing and use my calculator. So I'm going to put this in y1. I'm going to put this in y2. So y1 here is x squared minus 3x plus 6, and then 4x minus 4. Start with zoom 6 standard. And in this case, I can only see the bottom intersection point. So I go back to my window, and I'm going to change my y max to now be 20. See if I can see the 2 points. In this case, I can. So then I go to second trace, calculate number 5, intersect, press enter 3 times, and my first intersection point is at 2, 2, 4. Then I do the same thing, second trace, number 5, press enter twice. This time move my cursor up, closer to the other one. This time I get 5, 16, so my 2 solutions are 2 and 5. I hope this helps you. If you have struggles, again, make sure you email me. But hopefully this video will help you kind of get through this and make sense of all of 22.4 and 22.5.